Hello everyone, welcome to another Python video. In this video, we're going to be solving the prime number checker. The question goes as follows. Given an integer input greater than 1, determine if the input integer is a prime number. Okay. So we're going to be writing two solutions for this. Solution number 1, by counting the number of factors. A prime number should only have two factors, one at itself. So if a number has more than two factors, it can't be prime, it is a composite number. So from analyzing numbers from 1 to n inclusively, we're going to increase a counter until we find increase the counter when we find factors. Then after the iteration, we're going to determine if it's prime by comparing the counter, as in if it's greater than 2, it should not be a prime number. So here we go. First and foremost, we're going to grab a number and we're going to grab an integer input, enter the value of n. Okay, so that's set. We want to analyze numbers from 1 to n. So I know that it's going to end at n, start from 1. I have a finite loop. So I'm going to generate for divider in range, starting at 1, going up towards num plus 1. I added 1 there because I want to include that n value. Okay. Then it says here, so from 1 to n, increase a counter when we find factors. It's something that I am interacting with in the for loop. Therefore, what I want to do is counter set 0. This is initialized out of for loop so that we can manipulate it from the inside. So we initialize that from the outside so that we can increase this by 1 every time we find a factor within our for loop. Okay, within our for loop, okay, we need to determine if a number is a factor when we have learned already how to do that before in our previous video. So we're going to say that if we take our num that we're analyzing and say that divider is equal to 0, if then divider is a factor. We're going to increase our counter. The short form to do that is counter plus equal 1. It will increase the variable counter by 1 anytime this is true. And we end for loop. Okay. We've finished the for loop. We have done these two lines. So we're going to say after the iteration, we're going to determine if it's prime by comparing the counter. So we're going to say if counter is equal to 2, we're going to say print f num is a prime number. Otherwise, we're going to say print is a composite number. Let's save, run our program. $19. Okay, so let's check it with 2. 2 is a prime number. 3 is a prime number. 4 is not, because we can it has 1, 2, and 4 as a factor, so I have 3 factors. 5 is a prime. 6 isn't prime. It has 1, 2, 3, and 6 as a factor. 7 is prime. 8 is a composite number. Has 1, 2, 4, and 8 as its factors. Therefore, is a composite number. Okay, so in this question here, what we have to do first is, well, have our variable num, and it's going to be an integer input. We have to initialize a counting variable that we're going to manipulate within our for loop. Therefore, we must initialize it outside. Then we set up a for loop. We have called our iterating variable for our for loop called divider, and it's going to represent each number from 1 to num plus 1, so including all the numbers from 1 and num, which is what we wanted. Okay. And it says that we're going to increase our counter by 1, which is counter plus equal 1, anytime we find a factor. Right? When we take num modulus divider, and if that equals to 0, as in it was a perfect divisor for our value of num, then if that was true, our counter goes up because we have discovered that divider is a factor. After the for loop is done, we have unindented out. We have exited all these code blocks, right? And we set a new conditional statement. We said that, well, if the counter if it only found 2 factors, we know for sure it's a prime number because all prime numbers only have 2 factors, 1 and itself. Otherwise, we were able to determine that since it was not a prime number, we can safely say that it is a composite number. So that was our first solution. We're now going to code the second solution, which reads as follows. We're going to assume all numbers are prime until proven otherwise. And this is the steps that we want to take. All right. So number one, we're going to consider a number to be prime. Look at all the numbers from 2 to n minus 1 all inclusively. And we're going to say that n, well, it's going to be a user input greater than 1. If we find a factor from 2 to n minus 1, we know for sure it is not a prime number. If we don't find any factors from 2 to n minus 1, we know for sure n is a prime number because we weren't able to find any other factors for that number. Okay, and here we're going under the assumption that all n has a factor of itself and 1. Therefore, I don't need to check those two values. Okay, so let's code this. First, we're going to need another input. Enter value of n. Okay, and then we're going to consider number to be prime. So we're going to create a variable called is prime set to true. Okay, and then we're going to look at all the numbers from 2 to n minus 1. That is a finite loop for me. So once again, I need to use a for loop. So I'm going to say for divider in range. Instead of 1 to n plus 1, now we're going to go 2 to num2. And we don't add 1 to this because we don't want to include the value of num2 in our range. Okay. Then we're going to find if that divider is indeed a factor. So we're going to say if num2 modulus divider is equal to 0, divider is a factor, therefore num2 is not a prime. We're going to set is prime false, and then we're going to call break. This keyword allows us to exit the loop so that we don't need to check all the other numbers in our range because we get to exit early. We have now exited the code block of our for loop. Now we can just determine if our num was prime. We can say that if is prime. We don't need to do any Boolean comparison there because we're saying if this is true, then we can say print f. I'm just going to copy this one over. Right. We can say num2 is a prime number. Otherwise, we can say print f is a composite number. Cool. We're going to run this code. I'm going to give it a value of 12. 12 is a composite number. Give 12 here is also a composite number. Let's give it a value of 23. It's a prime number. 23, prime number. Both solutions are working as intended. Solution 2 is different. We were using break to help us terminate our loop faster so that we don't need to do necessary calculations. And we also don't do the necessary calculations of checking if 1 is a factor or if the number itself is a factor, because that should be determined that already those two numbers already are factors. We just have to find at least one other instance of a factor occurring between 2 to n minus 1 inclusively, then we can safely prove that that number is a composite number rather than a prime number. So that's how we generated the solution 2, like so. Okay, so solution 1 is great. It will check every single number and try to determine a factor, and it will count them all up. So this is a really nice factor counting problem. And this one is more a problem that was programmed, that was designed to catch prime numbers and composite numbers more effectively by exiting the loop early as soon as you figure out that the number is not prime. Okay, so please have a look at the solution. And as always, thank you for watching and stay classy.